Welcome to Pomodoro Joe for Thursday, August 10th, 2023. Today we're doing LeetCode problem 81, Search in Rotated Sorted Array 2. This is a medium problem. There is an integer array nums, sorted in non-decreasing order, not necessarily with distinct values. So that's interesting, we can have repeat values. Before being passed to your function, nums is rotated at an unknown pivot index, and then they give some constraints about the index. All right, so for example, 0, 1, 2, 4, 4, 4, 5, 6, 6, 7 might be rotated at pivot index 5 and become 4, 5, 6, 6, 7, 0, 1, 2, 4, 4. Given the array nums after the rotation and an integer target, return true if target is in nums, or false if it is not. You must decrease the overall operation steps as much as possible. All right. And then we have some examples. Okay, so interesting. Well, let's start with a simple example over here. Let's say we had 0, 0, 0, 0, 0, 0, 0, so on. Okay, so we have a bunch of zeros. How do we find out if they're asking for target index, or not index, if they're looking for target value 1, how do we know if it's in this? So based on our previous sort of rotated arrays searches, we would probably want to do some type of binary search. We might look at a high and low index, find the mid index, see if that's our target, and then choose which side to recurse on. Now with something like this, if we're looking for value 1, we don't really know where it is. In fact, it's not in here, but we wouldn't know that. Even if we split this into two sides, we'd then have 0, 0, 0 on one side and 0, 0, 0, 0 on the other side. So there's no real way to split this such that we narrow it down until we have only one element, unless we like recurse on both sides. So for example, if we are looking for 1, the 1 could be here, but based on this, we wouldn't necessarily know that. We'd split here, it's 0. We might think, oh, it's greater than 0, so it must be in this half. Well, it's not, it's in this half. And same thing here. If we had the 1 up in this half, we might split on 1 and say, oh, well, the mid is 0 and the high is 0. That must mean it must be in the lower half. So there's no real good way to tell which half it's going to be in, just based on this array at least. Now we might have better luck with something like this that has more values in it. Well, for example, let's say we're looking for 5. Well, at this point, we could split this and we'd find 0 here and 2 here. Now we know that everything between the 0 and the 2 must be increasing, because this is still a sorted array. So if it's in there, it would be somewhere between 0 and 2. All right, that's helpful. We could also do something similar down here. If we found a 6 and a 2, well, again, these must be increasing, so it must be somewhere between the 6 and the 2, if it's in there. But I think it still keeps devolving until we get to some case like this, where we just have a bunch of some value, and our target might be in there, but there's no real way of knowing just by doing a binary search type pattern. We really just have to do a linear search through these values to find out if our number is somewhere embedded in there. All right, so we'll put 25 minutes on the Pomodoro timer and we will get started. All right, as you notice, it doesn't say it has to run in O log n of time. It doesn't give us a specific runtime metric. It just says decrease the overall operation steps as much as possible. Now it doesn't define what the operation step is, and it doesn't give us a specific runtime requirement like an O log of n requirement. So you don't actually have to do an O log of n algorithm here. But I think I'm just going to be a bit cheeky here and use a single line of code. Let's just return target in nums. All right. That's it. Let's see how it goes. All right, we're passing. Let's submit that. And we pass. And we do really well. We beat 93% for runtime and 77% for memory. So yeah, this is, in my opinion, a great solution. All right, let's take a look at some other solutions. We're going to be a little bit different today. We're not going to go through and write our own solution, because I actually think that this is a totally reasonable solution. So let's see what other people are doing. Let's look at the best one so far. All right. Okay, so in this one, looks like, oh, they've got a bunch of specific conditions. They get the length of our array. If the length of the array is 0, then we return false. That target can't be in this array. If there's only one element in the array, we check to see if that's our target, and we can return true or false. If there are two elements in the array, we actually check each element to see if that's our target. All right. Now we get to the bigger arrays. We find the midpoint here. So this is going to be similar to our binary search. Check to see if the midpoint is our target. We can return true. All right. Otherwise, we check to see if the low value is less than the midpoint. If it is less than the midpoint, then we actually have to check the other values here. Is the midpoint greater than the target? And is the number at the lowest index less than the target? So basically we're looking here, is the target somewhere between our lowest index and this midpoint? If it is, then we can do our search on just that search area. So everything up to the midpoint. If it's not, then we do the high side. So if it's not in the lower half, then we'll check the upper half. All right. And then let's see here. If num0 is greater than the midpoint, okay, that means our split must be somewhere between num0 and the midpoint. Then we check to see if the midpoint is less than the target, and if the highest element is greater than the target. So the target is somewhere between the midpoint and the upper element. In that case, we'll just search the upper element. Otherwise, we search the lower elements. Okay, that makes sense. So this is all basically sort of the our standard binary search that we've done before. But we do have this one extra case here. So this extra case is saying our midpoint is not greater than our lowest value. It's also not higher than our lowest value. It's the same as our lowest value. So if that's the case, then it looks like they're going through while true. That's interesting. So this is interesting. They're actually finding unique elements that are between the first element, or the 0 element, and the mid element. At the same time, they're looking for everything between the mid element and the topmost element. So they're basically shifting the index on the low side, so from 0 through midpoint, and they're looking for some new value, so whatever value is not at the 0 index. They're also doing the same with the midpoint, so they're going from midpoint up to the high point, looking for values that are not the midpoint. And whichever one of those, I guess, results in a new value first, then we'll do a recurse on that. So we'll recurse from something up to the midpoint if we found a new value, or we'll recurse on the midpoint plus some index up to the high point if we found a unique value there first. And then finally, if we reach the midpoint, then we return false. Interesting. Yeah, this is interesting. I kind of like this. It's tricky though. Like, I wouldn't necessarily come up with this on my own. So you can imagine standard binary search up here while they can. If they find some point where they can't do a binary search because they have the same value multiple times, they set pointers at the very first index, index 0, and another one at the midpoint, and then they increase both of them sort of in parallel. So you go 0, 1, 2, 3. At the same time, you're doing midpoint plus 1, plus 2, plus 3. And whichever one of those finds a new value first, we found some new value that we haven't seen before, then we take that range, so from that point up to either the midpoint, if we found it on the low side, or from that point up to the high point if we found it on the high side. All right. So this has been a little bit different than my normal videos, but I think it's educational. I totally encourage you, anytime you come up with a solution and you get to this page, you can take a look at anybody else's solution. I always look at the ones that got a better score than I did. So if you jump in here, you can just jump around. Like, this was where we were. We did pretty well here, but you can see this one did much better. Check the next one down. They're pretty complicated. Look at all these comments. Wow. Look at the next one. Standard binary search. And this one's interesting. So they're just increasing the left up until the midpoint as long as they aren't finding any new values. Very similar to this one that got the highest. All right. All right. Well, I'm not going to go through and analyze all these, but I totally encourage you to jump in and check out other people's solutions. You learn a lot that way. All right. Well, I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.